Hello everyone, this is Nash. Just right behind me is a very famous formula when you one day become a first grader. Today our goal is try to prove it and practice how to use it. So let's get started. In order to prove this formula right behind me, the integration by parts formula, I can start from two functions of x. And let's say they are not multiplied by each other. And what I'm going to do next is I'm going to take the derivative of this term. And by using the product rule, it will turn out to be f prime of x and times g of x and plus f of x and times g prime of x. Quite simple. But my goal is to prove this integration by parts formula like the integral of u dv is equal to uv minus the integral of v du. So I'm going to replace the f and g term by u and v, these two symbols. So I would just say I would like to let u equals f and v equals g. But just before I do so, I would like to integrate all this expression, both left side and right side. I'm going to integrate all this term. And do not forget, here should be placed by dx. You should place dx right here. Alright, since this is already a derivative of this function, so by integrate this derivative term, it would just become itself. So the first term should be simply equal to f times g. Nothing changes. And on the right side, here's the interesting part. Just like I said before, I could simply set u equals f and v equals g. In this way, the du becomes f prime of x times dx, and dv becomes g prime of x and times dx. So now the f and g will just become u and v. And the first integral, f prime times dx, f prime times dx, this is actually du. And for g of x is actually v. So the first integral term is actually the integral of v du plus the integral on the right side. And f means u. And g prime times dx is actually dv. So the last integral term is the integral of u dv. We are so close. So next time, when you try to integrate a u dv term, you can just move the second integral term to the left side. Since here's the positive value, so when you move it to the left, you should replace the positive term by negative. So I can rearrange all these expressions, and what we are going to obtain is the integral of u dv is equal to uv minus the integral of v du. So this is the most, I cannot say the most, this is a quite famous formula when you become a first grader, the integration by parts formula. This is how we prove it. Alright, next, if I want to practice by using this formula, I can give you one example. One example, like you try to integrate, let's say x times e to the power of x and times dx. Just before this video, this problem might be a little bit challenging for you, I know that, but just before, after 3 to 5 minutes, look at this problem. This will become so easy. Why? Because you can simply set u equals x and v equals e to the power of x, and the du means dx, and dv means ex and times dx. So the first term, the x is u, e to the power of x times dx is dv. So the first term, what you are going to integrate is actually the integral of u dv. And by using the formula, the integration by parts formula, it should be uv minus the integral of v du. and uv is x times e to the power of x. All right, and try to integrate the v du. V is exponential function with the base e, and du is dx. This is exponential function with the base e, so no matter how many times try to differentiate it, try to integrate it, it always becomes itself. So this term should be x times e to the x and minus e to the x. And the most important part is I'm now integrating this term with no limits. With no limits. So you should put one more thing. Exactly, the constant of integration. The constant of integration, c. So this is the correct answer, finally. So this is the proof and the practice of the integration by parts formula. This is quite useful when you first learn calculus. Hope you like it. This is Nash.